Hi. Good afternoon, everyone, and good morning and good evening, online participants. Hello. I introduce the products of a company that is having corporate exhibits. Today, I have the four. I introduce the four companies. Okay, so I hope you will come and see them in person at the exhibition hall. Okay, so first company is Best Instruments. Okay. こんにちは。Hello, よろしくお願いいたします。Okay, so the first company is the Best Instruments. Okay, so the presenter is お名前が野田様。野田さん。Okay, so please introduce your company and the instruments, please.
すみません、ちょっと日本語になりますけど、弊社は基本的に
ごめんなさい、はい、OK でございます。はい。
弊社は基本的にですね、創業以来自動車排ガスの分析系を製造販売をさせていただいているメーカーで、各自動車メーカーさん、サプライヤーさん、あと触媒メーカーさんに、多数装置を実験装置を入れさせていただいているメーカーとなります。
はい。本日は、okay, so I introduced this company in Japanese. Okay. そうすると今日装置の方は、はい、今目玉となるものは何になりますでしょうか。
はい、昨今のですねカーボンニュートラル関係で、今までの排ガス分析系と呼ばれるものCO、CO2、THC とかそういうものではなくて、そこも踏まえて、お引き合いをいただいているのは水素系であったり、アンモニア計測、こちらは今トレンドになっているカーボンニュートラルで水素エンジンであったり、アンモニアタービンであったりが主流になってきてますので、今の、弊社の目玉としてはその水素系およびアンモニアを計測する FTIR というものが弊社の今主力になっております。でまた触媒でCCS とか CO2 を回収するための、触媒性能評価装置、ちょっと今回は展示はないんですけども、触媒性能評価装置で次世代の触媒を開発されているというお引き合いも多々いただいています。
はい、わかりました。この水素系なんですけれども、だいたいその計測できる濃度とか、時間分解能っていうのはどのくらいになりますでしょうか。そうですね。
弊社の場合は水素系と呼ばれ一つくくってますけども、検出原理を3つ持ってまして、G ガスクロと TCD 熱伝導方式とマスで、それぞれのお客様の用途に合わせてご提案しています。低い濃度であれば 1% 以下、5000ppm、で高い濃度では 100% までは、そこはお客様の、お打ち合わせによって適切な検出器を選ばせていただいて、ご提案をさせていただいています。またそれぞれの一長一短ありますので、GC ガスクロ方式であれば30秒周期のバッチになりますので、ちょっと連続では測れないんですけども、TCD とあとマスであれば、TCD に関しては、応答速度はだいたい1秒前後で、マスは2.5セックぐらいで応答させていただいてますので、そこは本当にお客様の用途ですね、によって変わってくるのかなと思います。
はい、わかりました。ありがとうございます。目玉となる水素とアンモニア系、非常に、いい装置を準備いただいていると思いますので、実験にご活用いただくというのがいいのではないかというふうに思います。最後何か、皆様へのコメントございますでしょうか。
ですね、まだまだちょっと弊社も営業努力が足りませんので、ベスト速記とは何ぞやというのはあるかと思いますので、この機会で少しウェブでベスト速記とアクセスしていただければなと思いますので、よろしくお願いいたします。
はい、どうもありがとうございました。はい、どうもありがとうございました。Okay, so はい、堀場さん。Next company is Horiba. Okay, so Hello. こんにちは。大丈夫でしょうか。よろしいでしょうか。はい、それでは。Okay, so the next company is Horiba. So the presenter is Yoshioka-san. Okay, so please introduce your company and the instruments, please.
Hello everyone.
持ってます。はい。
Hi everyone. I'm Yoshioka from Horiba Limited. I'm in charge of FTIR measurement system and hydrogen analyzer and so on. Today I'd like to introduce mainly two topics. One is hydrogen engine measurement system, and here is a representative schematic of a hydrogen engine measurement system. As you know, so we need a fuel flow meter and hydrogen engine itself, and engine dyno. Dyno means it can measure the performance of evaluation system for engines, and we also need to measure the particle matter PM and particle number PM by this system, these analyzers. And mostly we need to focus on the hydrogen. So we just released a new hydrogen analyzer we call HiEvo. And the last one is we also need to measure multi-component, including NOx. So today I would like to mainly focus on the new hydrogen analyzers. So this feature is, one is this hydrogen analyzer can measure hydrogen with high moisture content, up to 35% of H2O. So due to new technologies. So in this case, maximum 35% of water may contain in exhaust gas. In such severe condition, we can measure its hydrogen accurately. And the second one is this HiEvo can measure hydrogen with high response time, and response time is less than 1 second. And we achieved so. And the last one is we also contribute to saving the laboratory's energy, and by reducing the warm-up time. The previous one is more than 10 hours, but we reduced the warm-up time to 3 hours in this new system. The next topic is FTI exhaust gas analyzer. We call it FTX1CS, and here is a real analyzer schematic. We achieve the half size of previous FTL, and we can easily move on to test cell to next test cell. And here is a feature. And this FTX1 can also measure the multi-component up to 28%, 28 component with high moisture amount. And this high moisture means up to 40% water. And this also can measure this kind of measurement component with high response time. And also we achieve the sample flow rate is very low. The sampling flow rate is 3.5 liter per minute. So if we contribute to the system, especially for the very small size engine system, so in such a system, we need to consider to minimize the disturbance of the measurement field. So this will be the one solution, I think. So the next topic is PEMS system, on-road system. So the next one is Mr. Kitahara.
Okay. Okay, so thank you very much. So the next one is Kitahara-san. Introduce the PEMS. Okay.
My name is Takahiro Kitahara. I'm in charge of particle measurement system. So I introduce about real load emission measurement system called by PEMS. So Horiba provides two measurement unit. One is the OBS1XL. It's measures gas analyzer, and another one is OBS1PN can measure a particle number. So OBS1XL can measure two components. One is the ammonia, and another one is N2O. So Obison XL detector has a based on the QCL IR method, and with Horibat's new concentration calculation algorithm, Horibat is called RAN. So X1 OBS1 XL has a new technology RAN. So next is OBS1 and PN. I introduced OBS1 PN. OBS1 PN can measure the SPN10 measurement system. So OBS1 PN detector is a CPC, so it's the same as a stationary system. So OBS1 PN has a good correlation. So and other facts and OBS1 PN has an automatic zero check system function. So this system target is Euro 7 next to Euro 7 regulation. So thank you.
Okay, so thank you very much. So very, very interesting instruments. Okay, so now I have one question. So I'm very interested in this hydrogen measurement systems. So what is the size of the measurement system? It's almost the same one? Size?
This hydrogen analyzer is
Hydrogen,
very similar to this size.
similar to this size. Okay. So and the FTIR is also very, very small one.
Yeah.
So what is the flow rate of the hydrogen measurement systems?
This flow rate is also 3.5 liters.
It's the same, almost same.
Yeah, both.
Okay, okay. And I'm also interested in this one, the RAM.
Yes. Simple schematic.
Okay. Okay.
Yeah, we made this laser by ourselves. Yeah.
You also contrasted the QC laser.
Yeah, by designing the chip things, and we can change the wave numbers.
Okay, okay. Okay, so very interesting. Okay, so thank you very much.
Thanks so much.
Thank you. Okay, so hello. Next company is Marubun. Okay, so the presenter is Mizuno-san and the Thomas Berg-san. Okay. Okay, so please introduce your company and the instruments and so on. Yes.
Hello everyone. My name is Mizuno from Marubun Corporation. So we are distributor of LaVision GmbH, and today we exhibit to the measurement system based on some laser or some optical technology using for the combustion or some hydrogen measurement. In others. So at first. This is a ecosystem. So this is just one example for this is a glass engine cylinder, right? And laser or light is coming, and then it can measure for example, fuel or temperature or some water with a really high speed measurement, like 32 kilohertz or something. And so it's really good for the application to the measure for fast. How can I say in phenomena? Yep. Okay. Then next this slide for the poster is this is spray master inspects. So this is a measurement for the spray geometry. So for example, like a fuel injection or something for the quality control is also it's good for this system. And the next one this is particle master inspects. So this is based on the shadowgraphy technique. So which can measure for the distribution of the particle size, and also these inline system is also available for using for the spray dryer or in the more production area. So from it's can huge huge area for the market range from the R&D to the production. Okay, then next going to the robots. Then I pass to the this introduction from the Dr. Thomas Wang from the LaVision GmbH.
Yeah, Yeah, thank you very much, Mizuno-san, for introducing. My name is Thomas Berg. I'm the CEO of LaVision GmbH in Germany. We are located there, and we are developing imaging technology for fluid measurements, and are represented here by Marabun Corporation. I'd like to introduce to you our latest product. It's the FlowBoss camera, which intention is to visualize gas flows. And so this is the camera here, which is pointing to a background pattern. And if I introduce a gas flow, which I now simulate here, the camera itself can make this gas flow visible. Yeah. So, and we see different applications in this, especially in the field of hydrogen combustion in the near future, because this way is the only one where you can make hydrogen visible. Yeah. So. And especially distribution of hydrogen, or looking into hydrogen engines or gas turbines will work like this. The camera itself is very sensitive, so it is also possible to visualize heat. So if I hold my hand in here, you still see the heat schlieren from my hand moving up. So we use this also for heat transfer phenomena, and there have been also research or investigations for spreading of COVID and with a mask and so on. So it's a very universal way, and it's easily applicable like a video camera. And we especially hope in this field of fluid dynamics and visualization, especially for hydrogen, that we have a big impact on this one. Yeah, thank you very much. Also to Mizuno-san, that we are now have the chance to be represented here in Sapporo by Marabun Corporation, and we are really looking forward to what is going on in the next days of the conference. Yeah.
Okay, so thank you very much. It's very interesting. So I have one question.
Yeah.
So what is the mechanisms of the measurement systems?
Yeah. This is called background-oriented Schlieren, and Schlieren is a measurement technique which is known by having classical mirrors or so. It is like if you look over a warm street and you see the light flickering around, we use this flicker and visualize this from this pattern. So the camera is looking at this pattern, and if you are looking over the street and see this motion, we see the motion of the points here. Of course, if I do my hand like this with your eye, you do not see something. But the camera is so sensitive that it sees the slightest motion of these parts and makes the image out of it. And for instance, when you have hydrogen, the refractive index change of hydrogen will be then used to visualize it. So this is a technique behind it. Yeah.
Okay. Thank you very much.
Thank you very much.
Okay, so if you have some comments, if you have the audience.
Thank you today for the give the time for the explain to our booth. So we are waiting for your coming, or you contact some question. Please contact to us. Thank you very much.
Okay, thank you very much.
Thank you very much.
Thank you very much. Hi. Konnichiwa. ではよろしいでしょうか。Okay, so last one is the Honda Motor Corporation. So the presenter is President Kimura-san. Okay, so please introduce your company and your new engine.
Okay, welcome to Honda booth.
大丈夫です。持ちます。はい。
Welcome to Honda booth. I'm gonna explain about Honda EHV systems. This cutaway model is Honda EHV system, which is installed global small car like Fit in Japan and other countries, Crider in China and Jazz in Europe. This engine is 1.5 liter at Simpson cycle natural aspiration engine. Maximum power is 72 kilowatt and maximum torque is 127 newton meters. Fuel economy has reached around 30 km per liter. Now, let me introduce EHV systems. The biggest feature is that it switches between these three modes automatically. to take best performance of engine and motors. First one is EV mode. When you're starting and low-speed vehicles, this mode was used. Next, in the hybrid mode, engine generates electric power to drive motors, and the motor produces driving force in all over the driving area like this, regardless of the battery level. The last one is engine drive mode. When you drive high-speed cruising like this, the engine and the tires are directly connected. So then you can get the high transmission efficiency. Then you get the more fuel consumptions. That's all about Honda EHV system. Thank you.
Okay, so thank you very much. So I'm very interested in this system. So what is the maximum thermal efficiency of this engine?
This engine has reached 40.5%.
Oh, it's a brake thermal efficiency.
Yes.
Okay. Okay. So and which one is the electric motor systems in these systems? This one.
Yes, this one.
Okay. Okay, so thank you very much. So at last, please, and the audience.
Hello. I have no idea to speak something, but
Visit our website.
Mm-hmm.
Our homepage.
Okay.
Visit our homepage.
Ah,
You can say, please visit our homepage.
Soもしよければホームページへっていうようなところ。
なるほど。
はい。
ちょっと待ってください。はい、今撮ってますよ。
はい。生でございます。大丈夫です。日本語でも英語でも大丈夫でございます。
If you want to see know about more, welcome to our home pages. Thank you very much.
Thank you very much. Thank you very much. Thank you very much. Okay, so thank you very much. So yesterday and today I introduced the 8 companies. So this is all companies. So if you have interested in these instruments or the engines, please contact to each companies. So thank you very much.